Assalamualaikum and hi. My name is Muhammad NAWI bin AWANG KASSIM. Matrix number B018180033. My supervisor name is Siti Nur Suhaila binti Mirin. I would like to present my BDP1 presentation, which involved in a development of mobile robot for monitoring plant health and volume. To my project introduction. From the agriculture point of view, most mobile robots focus on improving overall production itself. The common robots that improve agriculture activity are harvesting, pest control, autonomous seeding, phenotyping, utility, sorting, and packaging. The goal of automation in agriculture is to improve production and quality while automatically lowering labor costs and operating time. Agriculture processes are complicated, diverse, and unique for each type of crop. However, despite the advantage of field and robotics, there are some challenges for mobile robots to overcome, such as environment, payload, power supply, visibility, navigation, and more. In this project, focus on the development of mobile robot monitoring plant health and volume condition using the image processing method that based on the normalized difference vegetation index, which is the NDVI formula. The mobile robot navigation method is a line follow robot by using an IR sensor where it decreases the maintenance cost itself. Before we go any further, what is NDVI? NDVI is a measure of state of plant health based on how the plant reflects light at a certain frequency. Some waves are absorbed and others are reflected. Chlorophyll, a health indicator, strongly absorbs visible light, and circular structure of the leaf strongly reflect the near-infrared light. When the plant becomes dehydrated, sick, affected with disease, and more, the spongy layer of deteriorates and plant absorb more of the near-infrared light rather than reflecting it. You can see here there are two trees, which is healthy tree and an unhealthy tree. The healthy tree reflect more near infrared and the unhealthy tree absorb more near infrared. Let's we go to our project's problem statement. In the advance of robotics, these are the main challenges in mobile robot in agriculture, which is environment limitation due to rough terrain and dynamic environment. Second is a navigation limitation due to unpredictable weather. For the project objective is first, to develop a mechanical structure, electronic parts and software parts of the mobile robot. Second objective is to control the movement of the mobile robot use line follower method using an IR sensor. The second objective is to display the health status of the plant through an IoT platform. For the project scope of my mobile robot, is to configure a land-based mobile robot using the best material that can withstand agricultural environment. Secondly, Raspberry Pi as a microcontroller and a line following method for robot movement using IR sensor. The Pi no infrared camera will capture the plant image and the Raspberry Pi will perform image processing to obtain the NVI image. Fourthly, the mobile robot only monitor a chili tree farming that placed in a 3-row flower pot. And last but not least, an IoT platform is used for the plant health status for collected data. For my lecture review, consists of agricultural mobile robot challenges. It consists of design, navigation, and image-based method. For the project methodology, we can see here this is the flowchart of overall project. But first, lecture review, where the study in the development of mobile robot and parts project analysis. Second, next we go to project design that involve in mechanical design. Next, hardware development, which is in circuit design and component. Then, software development consists of Raspberry Pi coding using the Python language. Then, coding, if coding successfully, go to result analysis, documentation, and end. So this is my project block diagram. Consists of the Pi no infrared camera, 2 IR sensor, the Raspberry Pi, L293 motor driver, servo motor, PC, and 4 DC gear motor. In the mechanical design, this design was created using the SolidWorks software and divided into different views, which are front view, side view, top view, and isometric. All components will be stored inside the robot. 2 IR sensor is in front of the robot, which is in here, and last but not least, the camera will place above the robot, which is in here. Next, we go to circuit design. So this is the project circuit design using a FreeSync software that evolved in a Raspberry Pi, connected with 2 IR sensor and connected with the Pi no infrared camera module, 4 DC gear motor, 1 motor driver, and last but not least, the power supply, which is the LiPo battery. Go to the list of components of the project, which is the Raspberry Pi to control as a brain for the whole operation, control sensor and output, the Pi no infrared camera with a blue filter which capture the plant image, IR sensor to detect color surface and determine direction of the robot, 7-inch touch screen to display the Raspberry Pi operating system, gear motor convert direct current electrical energy into mechanical energy, L293D motor driver which convert low frequency current signal to higher current signal, crossover motor to control the rotation of the camera, and last but not least, the lithium polymer battery which give voltage supply to the robot. Next, we go to the preliminary result for my project. Before we begin, what is the difference in digital image, multispectral image, and hyperspectral image? In digital image, only able to obtain a visible light which is consists of red, green, and blue, where the multispectral image have many filter image consists of gamma rays, ultraviolet, and it has a gap. But in the hyperspectral image, it contains more filter on the spectral light because it is continuous. So in my preliminary result, we're using a MATLAB image processing tool, where 2 spectral images will be inserted from the web into the MATLAB coding script consists of red image and near infrared image. Both images used and will be applied in the NDVI formula, and NDVI will be obtained. So this is the red region image and this is the infrared region image. And when we apply the NDVI formula, so this is the output, the NDVI image, where the type of crop is more than closer to 1, which indicates the plant is healthy. For the conclusion in my project, in conclusion, this project is very interesting because monitoring method in determining the plant health is different, where it uses an image processing method that based on the NDVI formula, and the IoT platform will display the status of the plant consisting of 3 indications, which are dead plant, stress plant, and healthy plant. The plant health status determines the near infrared reflectance by the plant itself. So it's challenging to complete this project due to identify of near infrared reflectance in the light spectrum. Although the monitoring method is explained, the line following robot has not been done, and it is not combined with monitoring method. There are much more implementation to do for this project, so this project able to be completed. So this is my Gantt chart for my BDP1 and BDP2. So that's all for me in the development of mobile robot for monitoring plant health and volume. That's all. Thank you.